Hi, this is Jeff Evans from Evans Performance Academy. We're going to be taking a look at some basics with our PC Link software so you can get started with your Link G5 or G4X system. Without further wait, let's jump in to check this out.
Okay, so let's get started. We're going to be taking a look at how to set up linear position sensors within our Link G5 and G4X programming. Now, a linear position sensor is going to allow us to translate a voltage to a range of movement. The most common type of linear position sensor would be a throttle position sensor. Now, we're going to always have a throttle position sensor input, regardless if we're going to be dealing with a cable-driven throttle body or drive-by-wire throttle body. We're going to be taking a look in this tutorial at how to set up a cable-driven throttle body throttle position sensor. It's fairly easy to go through that process. We're also going to be taking a look at setting up a shock position sensor. So this would allow you to measure the travel of your shock or suspension. That's good for doing suspension tuning. Learning how your vehicle is reacting in dynamic situations is essential data that you need for a suspension tuner. All right, let's jump in here and take a look at the most basic position sensor to set up. Again, that's going to be our throttle position sensor. First thing we're going to do is move from our basics window here, and we're going to jump over into our analog inputs. We're going to move down here, and the fourth window on the left, we're going to find throttle position sensor. Currently, we're going to see here that the TPS main source is set to none. The source is going to be where we've wired that throttle position sensor into at our link. Now, when we're dealing with a linear position sensor, whether it's going to be a throttle position sensor or a shock potentiometer, we're going to find there's three wires for that sensor. One wire is going to go to a 5-volt source supplied from our link. The other is going to go to a sensor ground, also tied into the link. And the last wire is going to be our signal wire, and that's what's going to translate a 0 to 5-volt range of input. And we're going to be able to correlate that to an actual movement once we calibrate things in our software. So what we'll find here is that the throttle position main source, we can see here under none, I'm going to have a bunch of different options to choose from. In my situation, my analog voltage input 1 is going to be my throttle position source. So that's where I've wired the signal wire for my actual sensor. We can see that choice right here. We can go ahead and select that. Now, if you didn't know which specific analog voltage input the sensor was wired into, let's say you're starting off with a fresh project and you don't know where someone has wired and set up a throttle position sensor, you can do some testing real quick. We talked about this in some of our training modules before this one. Let's go here to our tuning window under runtime values. Here, if we go back over to analog in our window, we're going to find that analog voltage input 1. I know where that's wired because I've actually personally wired this myself, the harness I'm working with, so I've designated that, and I have that in an Excel spreadsheet so I know exactly where my inputs and outputs are tied into. We'll find that that's sitting here currently when I'm off the throttle at 0.56 volt. Now, if I'm trying to figure out which particular analog voltage input is tied to my throttle position sensor, well, I can simply go in and actually just move the throttle pedal with our cable-driven throttle body, and we can see that start to move, and we can know that that's going to be our input. Again, I know that my input is tied to analog voltage 1, so I'm not going to go ahead and do any movement for right now, but we will find that's where I'm going to take a look here under my analog voltage inputs. Whatever is moving in terms of the voltage, as I'm moving my throttle in a cable-driven throttle body setup, that is going to be the input that we need to set up here for our main source. Now, again, I did mention that whether you're cable or drive-by-wire, you will have throttle position sensors to configure. We're going to have separate tutorials on setting up drive-by-wire because it is completely different, but note that drive-by-wire throttle bodies have 2 throttle position sensors, and they're not going to be calibrated in this particular window. This is only for a cable-driven throttle body for a single throttle position sensor. Okay, let's go ahead and close this window out, and let's go here and assign our main source to our analog voltage input 1. Let's click OK here, and now we're going to find we have a couple additional things that we need to correlate here and set up. So first things first, we're going to have our throttle position main closed voltage and throttle position main open voltage. What this is going to do is allow us to calibrate the throttle position sensor between its 0 to 100% opening in the throttle range and movement. Now, we know by going into that runtime value right here. If we jump into the tuning window, we know when I'm off the throttle, it's sitting here at 0.56 volt. Now this is going to vary based on whatever throttle body and throttle position sensor you're dealing with. They can be as low as 0.1 volt. I've seen as high as maybe 0.9, 1.2 volt. It depends again on the particular sensor and its position. That's how it's clocked on the throttle body. But we'll find that the typical range will be somewhere in that when you're off the throttle. Now, we could go in and just take a look here at what the main source is showing us and enter that in here for the closed voltage. Notice it's at 0.5 volt. So we could go in and start to set that up. However, we have a better way to do this, and the software is going to have an automatic calibration setup right here. So if we double click on this little wrench icon, the software is going to prompt us up with a screen. This is going to say here to press throttle to fully open position, and we can see right now it's correlating the default voltage values of closed 0.5 volt and open 4.5 volt. Specifically the closed voltage here of 0.5 volt, it's showing that my throttle position is open 1.4%, again because it's seeing an uncalibrated voltage of 0.56. So it's going to go through now and track when we go full throttle what the voltage is to set our open voltage, and then come off the throttle and set our closed voltage. So when we're looking here at our throttle position range between 0 and 100, it's going to track that accurately. It's super important that the throttle position sensor is calibrated right. Things like idle control, overrun fuel cut, and acceleration enrichment fueling all hinge upon the throttle position sensor reading and being calibrated correctly. So we absolutely want to make sure we're going through with this calibration process. Now for right here, we can see in this window, it's asking me go to the open position. So let me go in right now and let's go ahead and test this. We can see right now I'm going to go all the way full throttle, and we can see right here it's showing 97.2. Now obviously, we could just take a look at our window here. Obviously it's not calibrated. So when I click OK, notice that it's showing now at this particular throttle position all the way to the floor, that's 100%. And if I come all the way off the throttle and come all the way down again, so I'm going to be off the throttle here, we're going to show it's 2% when I'm off the throttle. If we click OK, now notice that my closed throttle position is showing approximately 0%. So it now knows my 0 to 100% movement that's specific for my throttle body and my throttle position sensor. What we'll notice here is that the closed and open voltage have changed and they're highlighted in blue because we haven't stored this information to the link yet, but it has been calibrated. So we know the throttle position sensor is dialed in and we can rely on it for reading for things like idle control, the overrun fuel cut, and the acceleration enrichment. Okay. So the next thing I'm going to do here is just go and do a store. So Control S, you can see it's performing a store. Now that information is no longer highlighted in blue because it's actually been stored to the ECU permanently. The next thing we want to take a look at here is going to be the error low and error high values. Now, this is going to say below this volt or above this volt that there is a problem with our throttle position sensor circuit. This is important because if we have a fault, let's say the sensor comes unplugged, or something happens and the sensor is damaged, we want to know that there is an actual fault being detected. So the link can then flag that as a status and report that to us. So what we want to do here is take a look at our closed and open volt. We know that the minimum volt is 0.59 and the open volt is 4.39 volts. So that's going to be our range of total voltage movement. Here on the low, I would say probably put this about 0.2 volt lower than whatever your closed voltage is going to be. So in this case, I'd probably put it at something like 0.39. We know the voltage can't go anything below that. Then the high voltage is 4.39. We want to go slightly above this. So in this case, I'll go to something like maybe 4.59 and we'll enter that in there. That's going to give us a pretty reasonable range for error detection in our throttle position sensor circuit. The last thing we want to do here is if it goes below or above our error voltages, that we take a look here at the error value, and this is what the throttle position sensor is going to default to. So if it faults out, it'll go ahead and it'll trip the detection and it'll go ahead and default at a 0% if there is an open circuit or some type of a damage to the sensor. Generally speaking, 0% is sufficient here, so I'll leave 0 for the value we populate, but you could go in and populate it at something like maybe 5 or 10% throttle so that it would have something other than 0 in there. It's really up to you how you want to handle this, but I'm going to leave it at 0. That should be completely sufficient. Let's go ahead and perform a store and store that to the link. All right, so the last thing we're going to take a look at here for the training tutorial is going to be setting up that shock position sensor. So the shock position sensor is going to be a 0 to 5 volt output typically from the shock position sensor itself. You'll have 3 wires, just like a throttle position sensor. We're going to have a power supply, which is 5 volt from the link. We're going to have a sensor ground. We need to go and ground back to the link. And then we have our signal output that we're going to go ahead and wire in to the link. And we need to go and designate what that specific analog voltage input we're wiring our shock position sensor into. In order to set up a shock position sensor or another type of linear position sensor that we can translate a voltage to a movement reading, we're going to be using a GP analog input, so the general purpose analog. We do have some other options here, such as general purpose pressure or general purpose temperature, also general purpose rotary switch, but we're not going to be using those for a shock position sensor or any other linear type of sensors. We're going to work with our general purpose analog. So let me go through and setting this up real quick. First thing we're going to do here for the label, let's assume that we're running multiple different shock position sensors. Let's say we're running them in all 4 corners of the vehicle. You might say left front shock pot, and you could also, it looks like the maximum characters have been reached. I was going to say you could also designate it as the total travel of what that sensor can actually measure. So you'll find shock pots will typically come between 0 to 50 millimeters, 0 to 100 millimeters, 0 to 150 millimeter. There's lots of different ranges that they can actually read in. So depending on how much travel you have to measure, you're going to pair the shock pot to that specific range of travel. So I'm not able to put those characters there, but I'm working with a 0 to 100 millimeter shock pot here for the setup and configuration. If I click OK, we have to assign this to a source. So we're going to go in here and I'm going to be using analog voltage 4 as the input for the shock pot. We have our error low and our error high and also our calibration. Now under the calibration here, we're going to be using a calibration table. We could use a linear calibration table or a normal calibration table. We've talked about the linear calibration table when we were setting up our map sensor. And then we talked about setting up a calibration table for something like our intake air temperature. This would be assuming that something is an unlinear type of curve like a temperature sensor. So in this case, I'm going to use my linear calibration option 2 here. I'm going to go ahead and select that in my list. So we'll go ahead and grab that. Now in the linear cal table here, we can say 0 to 100 millimeter shock travel. So we can actually designate it right here. Now the input values here. So we have input value A, input value B, output value A, output value B. This is pretty simple. We need to know the total range of movement for our shock pot in terms of the travel, and then also what it's going to output in terms of voltage. If we take a look real quick here, I have a data sheet open for a shock pot that I use pretty frequently. This shock pot, they have a different range of movement. If we kind of go down here, they're gonna have different options here, all the way from 25 millimeter up to 300 millimeter for the actual travel range it can measure depending on the part number. And again, your travel range you're trying to deal with, you'll choose one of these options. From the data sheet here, if we go up, and we actually can take a look in the schematic here before we do that, we're gonna find that we have a shielded wire, then we find a brown, black, and blue. These are going to be specific for that power ground signal. We actually can find that here. The brown wire would be power in, signal output would be black, and then the ground would be blue. So we have to pay attention to that wiring for the specific shock pot we're working with. In this case, when we're looking at our DC power in, we're supplying a 5 volt power reference from the link to power the sensor. So what we're gonna find here, if we scroll up, we're gonna see the output of the sensor is 0 to 100% of the input voltage. So that's going to mean if we're supplying it with 5 volt from the link, then we're going to expect it to go from 0 to 5 volt. It's actually a really simple circuit. And because I'm using a 0 to 100 millimeter travel sensor, 0 millimeter is going to be the equivalent of 0 volt, and then 100 millimeter is the equivalent of 5 volt. So very, very simple. how do we set this up? Let's jump in here real easy. Go back into our software. So we're using this linear cal. We're going to say the input voltage A, that's the lowest voltage, 0 volt. Input value B, that's going to be 5 volts. So 0 to 5 volt. Then the output, what it's going to translate at 0 volt, that's 0 millimeter of travel. And at 5 volt, that's going to be 100 millimeter of travel. Now the output units, we can change this to distance and click OK here. Now what we're going to find is this is set here on feet. So this may be kind of an odd measurement here. We'd have to actually convert that from millimeter to feet, which isn't really useful. We could go in here and let's see what the units, if we switch them to metric and we take a look here, we have to go back into our options under metric. We're looking at we do kilometers per hour. It's probably going to change that distance unit. No, it looks like it's still staying at feet. So what I can do here is actually just take out distance and leave it as none. And because I know here that I'm designated from 0 to 100 millimeter, I can make this simple 0 to 100. So if I look at a data log, it's not going to have a unit assigned to that shock pot travel, but it's pretty easy to understand what the value actually represents since I'm setting all this up, and it makes sense. It's just going to be a 0 to 100 right here. So I'm not going to actually assign a unit to that because again, we can't change that from feet to something like meters or millimeters. So it's best to just leave no units on this because the shock pot scale is in millimeters, 0 to 100, 0 to 300 millimeter, again, depending on what we're using. So what we can do then, if we're setting up a general purpose analog 1, if we want to set up multiple different shock pots, we could go in here into our ECU settings and we could find that from our list over here. So we can see I have a couple more different analog inputs, these general purpose. I could go and double click here. That'll open up another window, which we can find here, and we can slide that into place and start to build out our actual our workspace here if you want to go and add more analog inputs. For right now, I'm going to go ahead and delete that, and we can just keep what we have here just for the singular shock pot for this demonstration. Now, the other thing to keep in mind here is that our travel range is 0 to 100 millimeter, but 0 to 5 volt. When we're looking at our air low and high channels, we need to make this 0 and then 5, and then put the error value at 0. We don't want this to try to fault out because our actual true range of voltage measurement is 0 to 5 volt. We can't put the low voltage any lower than 0, and we can't put the high voltage any higher than 5. So in this situation, just set it to 0 and 5, and you won't unfortunately have any detection error capability on your analog position sensor here. So not the end of the earth, but just be aware that we want to set that. Otherwise, it's going to constantly flag and trip this particular errors here on this analog 4 input, and you'll be constantly clearing them out. It'll be kind of annoying. Let's go ahead and store this. So we're going to do a store, Control S. We're going to store that to the link. So all of this data information here is saved into our link now. So that's going to be it for taking a look at setting up linear position sensors. It's pretty straightforward. You absolutely, shock pots are going to be something optional you most likely aren't going to have, but you absolutely want to make sure you're setting up your throttle position sensor before you do any actual tuning. It's one of the very first things we want to do as we're going through and setting up our inputs and our outputs. We want to make sure that this is calibrated because again, it impacts a lot of other calculations and things in the link, but it is very straightforward to do.
Thanks for watching our tutorial. If you're interested in learning more about how to tune your Link G5 or G4X system, check out the video description below where you can find links to our school, some promo codes to get you started and save some money. If you're interested in learning more about Link engine management products, also check out the video description below. That's going to wrap it up here. I hope to see you guys in our school.